Hi everyone and welcome back to this channel. Today we are going to be looking at the stack data structure. One of the most remarkable data structures in computer science is the stack data structure. It is very simple to implement and yet very powerful. Today I'm going to be teaching you the introduction to this data structure and how you can understand it at the very basic level. Okay, so what are we going to be looking at in this video? First, we're going to be looking at an overview of the stack data structure, and that includes what is a stack. Okay, then when and where can a stack be used? We're going to be looking at the complexity analysis of a stack. Then we're going to be applying the stack data structure to solve a problem. So we're going to see a stack usage example. In the next video, we're going to be looking at the implementation details of a stack. So kind of an overview of how a stack can be implemented. Then finally, we're going to be looking at the code implementation of a stack. So how we can build a stack from scratch using code. That being said, let's continue. Okay, so what is a stack data structure? A stack is a one-ended linear data structure that follows a particular order to perform its operation. The order is called LIFO, meaning last in, first out. So what does this mean? So imagine you have a pile of data that looks like this. Okay, so if you want to add a data, then you have to add it from the top, right? And if you also want to remove a data, you have to remove it from the top. Okay, so just in case this is confusing, let me show you a real life example. So imagine you have a pile of plates that looks like this. If I ask you to add a new plate to these piles of plates, where are you going to add it from? Is it from the top or from the bottom? Of course, you're going to add it from the top, right? And if I ask you to give me a plate, okay, would you like to get the plate from the bottom or from the top? You would like to get it from the top, right? Okay, so this is the exact behavior of a stack. In a stack, you add data from the top, okay, and you remove data also from the top. So that is what a stack is. Okay, so at the left here, we have a set of instructions that we want to perform that describes which data we want to add and when we want to remove from the stack. Okay, so this is the stack over here. So the first instruction here is the pop operation. So pop means you want to remove a data from the front of the stack. So at this stage, you can see we're about to remove book, right? So now book is gone. So the next instruction is to push biro into the stack. So you can see that over here, right? So we want to add biro to the front of the stack, right? So boom, right? That's it. So the next instruction is that we want to push pencil to the front of the stack, as you can see here, right? So next, boom, that's been added. So we've added pencil. So now we want to push eraser, okay, into the stack. Okay, so we have it over here. Okay, so boom, right? Then now we want to pop out of the stack. Okay, so we're gonna pop out from the top, right? So we're gonna pop eraser out from the top, then boom. Okay, so now eraser is gone, and now we want to pop again, which is the pencil. Pencil is the element at the top of the stack, right? So then boom, right? So the next instruction is to push sharpener into the stack, right? So as usual, we're gonna add sharpener to the front of the stack, as you can see over here. So boom, right? So that is how the stack operates. So you can see the way it behaves in each instruction, right? Okay, so when and where is a stack used? Okay, so a stack is remarkably used nearly everywhere. Okay, so for example, it can be used to model real life object arrangements. For example, a pile of plates, like what I showed here, you can see. And you can also use it to model games, right? For example, the Tower of Hanoi. Okay, you can search that online. It is called the Tower of Hanoi. You can use a stack to model that. Okay, so a stack is also used in the compiler uh, to check for matching brackets. Okay, so a stack is used to ensure that there are correct numbers of matching brackets and that the brackets are arranged in the right order. Also, a stack is used behind the scene to support recursion by keeping track of previous function calls. Okay, so when a function returns, the stack frame is popped out of the stack and it rewinds to the next function at the top of the stack. Okay, so I mean, it's quite funny that we use stack a lot in programming and sometimes we are not even conscious of it, right? So next, we use stack for the undo mechanism in the text editor. So for example, you type something, then you deleted it, and you want to revisit it, right? So that mechanism can be implemented using the stack data structure. And finally, a stack can be used to implement a depth first search in a graph. Okay, so the depth first search can be implemented manually by you maintaining your own stack, or you can also make use of recursion, right? But guess what? Both of that uses a stack, right? So either you maintain your own stack or you use recursion. You still need to use a stack. Okay, so that is some of the uses of a stack. Now, let's look at the complexity analysis of the stack data structure. Okay, so this complexity assumes that the stack was implemented using the linked list. Okay, so you can implement a stack using an array. You can use a singly linked list. You can use a doubly linked list. Okay, but to obtain the best performance, it is better you make use of the singly linked list. Okay, so to push to the front of the stack, it takes a constant time, as you can see over here. Okay, also to pop from the front of the stack, to remove a data from the front of the stack, it takes a constant time too. Also, the pick operation, meaning that you want to check the data stored at the front of the stack. That is the meaning of this operation. Okay, that takes a constant time. Okay, however, to search for a data in the stack, it takes a linear time. Okay, that takes a linear time. To check out the size of the stack, that takes a constant time also. Okay, most times you're going to save this somewhere, so you can always call it and you get the response just once. Okay. All right, everyone. Thank you for staying till the end of this video. In the next video, we are going to be looking at how you can use the stack data structure to solve a real life problem. Okay, so you don't want to miss that, right? So please hit the subscribe button. Okay, so by subscribing, you're gonna be notified when a new video comes out. So please don't forget to hit the subscribe button. Thank you very much and see you in the next video. Bye.